this is algebra. Simplifying algebraic expressions is definitely going to be algebra. So I'm going to put us in here for simplify algebraic expressions. So let's welcome x to our repertoire. X is the most commonly used variable. A variable is a number value that we're not sure of. We have to do work to find out what its value is. Variables are unknown. Values are the solid number values that they get. X is the most commonly used one. That's kind of too bad. It looks like a multiplication sign. S is kind of bad. S looks like a 5. O is really bad. It looks like a 0. There are certain letters that just aren't good ones. It surprises me that they decided to go with X. But they went with X probably because it has very few words that start with X. But X is commonly thought of as a variable. Here's what I'm going to say about simplifying algebraic expressions. Number one, these are things that you don't have to do in order, but you have to keep all three of these in mind. Always alphabetize. You need to know your alphabet. Your variables. And it happens again, I'm going to say it, in each term, not over the whole expression, but in each term. So until you reach a plus sign, when it's properly inserted to deal with the negatives that might show up for you, keep its base in power. So what happens is if something has a power with it, it takes it where it goes. That power is going to be a part of the factors. Factors are things that are multiplied. Terms are things that are added. We're going to have a bunch of letters, variables, maybe a number in the front, could even be a fraction, could even be negative, but the number will come first, the letters will follow. Letters might have powers. We want those letters to be in alphabetical order. That way we can tell which ones match up. If they're allowed to just jumble up their letters, then it's hard to tell when they have the same thing going on, and that would mean whether they are like terms later on. Okay, this is not new to you. Terms are separated by plus signs. Sometimes they're blue because I put them in there, sometimes they're already there, but terms are separated by plus signs. So it's kind of important you know that you don't alphabetize everything you see in that expression. You alphabetize up to the first plus sign, up to the second, up to the third, after the plus signs have been dropped in. 3, the coefficient. This is a vocab word, so I'll underline it. Formal name for the number out in front. And I'll say it is the number ahead of the variables, and it will go first. It's larger than the variables generally. It does the counting. Might even tell you if it's negative. Could even go into decimals, could go into fractions, but there's a number out front that has no letters in it. That is your coefficient. Any unwritten coefficient, just like any unwritten power, or power, right? If you don't see a written power, then the power is 1. If you have 1 of something, you don't say, hey, I have 1 car. You might say, I have a car. Some people even say, I have car, right? Depending on the language. You have 1. If you have more than 1, you got to say so. So what's important here is the number 1. I'm going to write that in red because a lot of times I'm going to put my number up there so you can see it as a red 1, whether it's a big 1 for a coefficient or a little elevated 1 for a power, right? Later to be known as an exponent. So I'm going to ask you to do this. Name the coefficient in each term. I'm going to escalate the difficulty as they go across the board, but I'm not going to change the rule. Okay? I have here 2x. I have here negative 13x to the second y to the third, also known as negative 13x squared. Squares have 2 equal dimensions. Y cubed. Cubes have 3 identical dimensions. Those are the only ones with fancy names. Finally, negative 5. AB on top, 2 on the bottom. We're looking to name the coefficient. 2. Two is in front of x. That's x to the first. If I wanted to put my powers there, I could certainly put the 1 up here. It's 2x to the first, commonly referred to as 2x. 2 is the coefficient. Try the next one if you think you got it before I get there, or stop the video that you're watching. Make sure you catch everything from the number that sits in front of the x squared y cubed. Coefficient, negative 13. X squared y to the third, I call that the label. I'm the only one in the world, until I teach my students this, that I know of calling that the label. That's not an official math term, but what we're going to go with is like terms have identical labels. And now you know how to combine like terms, pretty much. So that's what I'm going to call that the label. Let's look at this one. We'll do an intermediate step. I'm going to realize that that has a negative 5 over 2. Those are what the numbers are doing. And then it's got its A and its B, and they're over 1. So it's negative 5 over 2, and the AB over 1 is just AB. So it's not that the AB are actually permanently always in the numerator. They could have powers of 1 if you needed the powers for any reason that ever comes along, so it's good to know. But I don't need the 1 under the A and the B, and yet my coefficient here is negative 5 over 2. It's not just negative, it's a fraction. It could be a positive fraction as well. Your coefficient is the number sitting in front of all your variables. I call the coefficient the number sitting out in front of your label. The label is going to play a big role in the way I teach like terms. And teaching like terms with the keywords keep the label. Okay? If you know keep the label, you are ready to combine like terms. What's a label? I've already explained to you. The label is everything after the coefficient. And I want to expand on that a little bit for you. When you get into a higher level math where there's a radical, where there's a letter that looks like I, but it's a little squiggly, when there's pi, all these things are part of a label. Because they're not numbers, they're part of a label. And knowing that the idea of combining like terms stands for keeping the label while combining the coefficients works all the way up through complex fractions, through things involving pi, through radicals. Keep the label. Okay, I'm going to put that up when we're doing our combining of like terms, but we have to know what the label is. The label is a JLK creation. I did not copyright or patent it. I hope other people use it if they find it easier to learn how to combine like terms. Here's the story. Like terms may only have their coefficients being able to not match. Everything after the coefficient is what I call the label. So I'm going to say this in my phrase. This is true. Like terms may only have their coefficients being able to not match. Everything else has to match. Why don't we come up with a name for what's behind it? I don't know. I guess people like to keep math difficult, and so only a few of us can understand it. But what I've come up with is the name label. And a label is everything after the coefficient. So I'm going to write that right here. JLK calls everything after the label, after the coefficient. All of that is legal math words. Even the word the. But label, that can get me in trouble. Because now I'm not talking legitimate math words. I'll take my chances. I think a lot of people have learned about what the label does, what it means, and how it applies to combining like terms, and then they can back into knowing what's going on with math instead of me saying, "What did you do? You added the exponents? What's the matter with you?" I don't have to do that, right? All I'm going to say is, did you keep the label? If you say no, then I'm like, you can't do that, right? So let's go with this idea. Number one, if we are using the word label, then we're going to say like terms must have matching labels. Matching means they're perfect matches, not kind of close, identical labels. So everything after the coefficient must match. Now you've done the job of putting it in alphabetical order so you can see if they match. Okay, if you got CAB and somebody else has ABC, both are required to put them in order. ABC is what it is, they match. Okay, CAQ is not going to match ABC because the Q is there, right? So matching labels. Put them in order, alphabetical order, so you can see the matching labels. Number 2, only like terms can ever be combined. I don't get in trouble for that at all. It doesn't mention labels or anything like that. Labels are helping you determine what's a like term. That's a rule. That is a rule every math teacher has to enforce. Whether they say it that way or not is up to them, but only like terms can be combined. If the terms are not like terms, they are not getting together. When combining, which is adding, or if they're negative, you might think of it as subtracting, but maybe there are negative coefficients. Like terms. Okay, here's something, the 3 words, that's all it takes, with a little tolerance of the term label. All you have to know in order to properly combine like terms is keep the label. If you keep the label when you're doing your combining of like terms, and you don't leave any like terms out there not being combined, right? You do the whole job, you're going to get it right. That's it. Wait, that sounds like gibberish. Keep the label. Put them in alphabetical order. See if the labels match. If the labels match, when we're combining like terms, we're adding or subtracting the numbers, which are the coefficients. So we're only going to combine ones that are like terms, and we're not going to force together anything that's not. So I'm going to say this, combining like terms means to look for matching labels to check and stack. When you get a like term, you're going to put a check at the top of it, and you're going to move it to the stack of those labels that already exists. Number 2. Combine terms. Let's see. So these are the concepts above. These are the steps below. Check and stack. Right? You got to put your plus signs in. We know that from other work. We've always put the plus signs in. We're not leaving minus in there. Plus negative, right? Plus the opposite. Inserted plus signs. Combine, which is add or subtract. Each column's coefficients. Those are their numbers. Keep the label. When you put a check above something, it is moved, it's no longer a column. It has been used up, the check indicates this has moved somewhere else, it's no longer having a value right in this space. So look, keep the label up there, keep the label there. Here's the story. If you promise to keep the label, you cannot combine terms that are not like terms. They can only get together if the labels match, because your destiny is to keep that label. If they're 2 different labels, then you have to ask yourself, which one should I keep? Should I keep the big one, the small one, the one I like, the one that came first, the one that came second? None of those questions have a good answer. Keeping the label is your only option. We can only put things together if they belong together, which is because they are like terms. Like terms will have identical labels, and our goal is to keep the label. If you try to keep the label and they don't match, you can't keep it because they don't match. What is he talking about? Here we go. 3x plus 10x. 20a minus 10a plus 4a. 3y minus y plus 8. We want to simplify these expressions by combining like terms. Let's look at what happens. Keeping the label, I got the blue because the labels are going to match. 3x has x as a label, 10x has x as a label. I'm going to put a check above my 10x, and I'm going to keep it as 10x and put in the x column, which is where the 3 already is. Guess what this becomes? Because I was doing addition, this thing is going to be done when I get my 13, 3 plus 10, and I keep the x. Okay, two things. They matched to get there, and they stayed x. It did not become 13x squared or 13x to the third if I have 3 terms. It is, how many x's do I have? 10 and 3, they're all x's. Let me keep the label behind the group of them. Next, I got 20a minus 10a plus 4a. I'm going to insert my plus sign there, as you know I will. So now I have 3 terms, 20a plus negative 10a plus 4a. Okay, negative 10a, I'm going to move, and what do I put here? Now, every time I say that in front of the class, someone who's taken algebra not highly successfully before wants to say, put plus 10a. It's negative 10a. Because that's what it is. I just moved it into a column, and this is plus 4a. Okay, now I'm going to get what that is, and then I'm going to address what some other teachers do and why it's bad news. Okay? 20 plus 10, you want to do that? 20 minus 10 is 10, 10 plus 4, that gets me 14. The label is being kept as A. This is 14A. Because I take 20 A's, toss away 10 of them. I now have 10 of them, they're still A's. And now I add 4 more, I got 14, they're still A's. They didn't become A cubes for any reason. This is what like terms have me doing. I'm going to grab orange because what I'm about to do is so heinous that I don't want you seeing it for very long. You can trap it on the screen, but it's off. It's like highly toxic having this orange marker out because it's just so bad. I want you to know, you may have seen this from other teachers before, this is much more solid. We are looking at a single expression. There is no equal sign here. I do not put a plus 10a here and then scratch that out, okay? I don't. I save that up for when it's really necessary. So if your teacher did that, I think there are better ways to do it. Others will say, well, that's just your opinion, and that's true. And I'm not going to punish you if you do that. But if you get it wrong, I'm not going to mark it right. And if you get it wrong, I am not required to have sympathy for you. Because I'm telling you, that is bad news because it makes it too confusing when we start solving equations later. Instead, we're working only on what we've learned in this class so far, and we're looking here to combine like terms. So I don't want to see that. I don't want to see this. When you are going to get in there and combine like terms, I am really going to want to be seeing for growth and foundational skills, I'm going to want to see you combine them, hopefully in columns. You don't need the columns, but you've got to get 14a, and I don't want anything scratched out around here. The check means it's been moved. That takes the effect of wiping it out, but you don't need to scratch it out because they might give you some, I'll call it explanation by being kind, that, well, I'm subtracting 10a here and I'm adding 10a here, and so that's a net of 0, so it's all good, right? And you're just like, yeah. Nobody really truly understands what's going on there, so I want to do this. I want us to be able to get that. Let's try the next one. Before we proceed, I want to remind you that not all terms are like terms. Okay, repeat? Sure. Not all terms are like terms. 3y minus y plus plain old 8. 3y plus negative y plus plain old 8. 3y plus negative 1y plus plain old 8. Why does he keep saying plain old 8? Let's watch why. 3y has y as a label. Negative 1y has y as a label. Check. It's going under the 3y. What's the label on 8? There is none. It's plain old 8. It's the number 8. It is not a y term. Not all terms are like terms. Only like terms get together. If all terms were like terms, we wouldn't need to know what like terms were. We would just always add everything together and see that we get, and we'd always have one term for our value. I've seen it. I don't like it. I work with trying to improve it. But only like terms can be combined. So now what did happen is 3 minus 1, or 3 plus negative 1, really gets me a positive 2. Subtract for 2, strong on the positive, like the 3. Keep the label as y. We have another unchecked column with the 8. Nothing changed it, so this is 2y plus 8, and we've combined like terms. This is something to go back over when you're struggling with like terms to get to the core value of what goes on, right? What has to happen when we combine like terms? I'm going to erase a lot of what's on the board because you can always go back and reload the video. So I'm going to erase a lot of stuff that's on the board. I'm going to erase almost everything that's on the board. It's going to take me a little while, but the drama is worth it. It emphasizes how important it is that certain things have to be done in order to succeed. Certain things have to be followed as rules. Do you have to do the process exactly the way, step by step, that I do? No, you don't. But may you only combine like terms? That's true. I don't care who your teacher is unless they're teaching you things that are wrong. I mean, we all make mistakes once in a while as teachers. But they're actually teaching you wrong if they ever let you combine terms that are not like terms. We know I call something the label, right? That's mine. I'm not embarrassed by it. I'm very proud of it. But here we go. Two of the most important things in this class, the entire course, are on the board. Oh wait, it's really one thing. That's how important it is. When you are combining like terms, you're looking for this idea of keeping the label. So now I want to take this one, negative 4x squared plus 7x. And it points out something about what these reduce to being and what our job is, like what our responsibility is to get through combining like terms. We are asked to simplify this expression. Some people will phrase it as simplify this expression if possible. And so what we're going to do is we're going to go through there and we're going to look, and I'm going to see one thing I can do with the red marker, which is to turn this into 7x to the first power. Now, the label on this term, the coefficient on this term is negative 4. The label is x to the power 2. The coefficient on this term is positive 7. What's the label on that term? I'll give you time to think about it, or you can stop the video and give it some thought, but here it is. That's x to the first. Is having x times x the same as just having x? The answer is no. Do the labels match? Again, the answer is no. Do these like terms combine? Again, the answer is no. Nothing happens here. Maybe you put the 1 there, but if this is a question that says simplify if possible, you can't just leave it there and say it can't be finished, so I'm going to leave it there and Kenosis is going to give me the points for it. No, you have to do something, right? You might want to do this. You might want to do equals negative 4x squared plus 7x, and then put a box on it, because I like to talk about us going to the moon. Yes, the U.S. got there first. And you know how we know? Well, let me put it to you this way. If we sent men to the moon, or women at the time, it was men, and we just got to the moon and we're like, this is pretty cool. We got here first. Okay, guys, let's go home. Then the Russians could easily say, there is no way they went up there. So, we left a flag. We left some sign of having been there, even though pretty much we left the moon the same way. Here, you got to leave some sign of the fact that you considered combining like terms, chose not to, and know they shouldn't be combined. Because if on a test that I'm grading for you, I see that without anything written, I'm going to think you just skipped it. You had no idea what was going on. You didn't even try. So if it stays the same, let me know that it stayed the same. That's my rule as far as getting through things that can't be reduced. But it is possible. Some things can't be reduced. The labels don't match. That's x squared. That's plain old x. They don't match. If I tell you to keep the label, what are you going to do? You can't. Therefore, they cannot be combined. You do not make it into a label of x to the third just because they're both x's, and that would be much nicer to have fewer things on my paper. No. Like terms are the only ones that can be combined. Still burning on the board. Keep the label. Distributing. Often called distribution, right? If you distribute stuff to everyone, you give a little to everyone, right? If you have, 100 M&Ms and there are 10 people in the class, then say, listen, distribute them evenly, every person gets 10. You're passing them out. to everyone. So distributing is sharing a multiplier which is called a factor. I'll underline it instead of doing that. Factors the name. Things that get multiplied are called factors. So when you learn factoring in 136, you're learning how to create multiplication. And you may notice that when you create multiplication, somehow parentheses have a tendency to appear in the work you're doing. Sharing a multiplier, which is called a factor, with each term in the parentheses. Now, I'd like to let you know the factor that you're going to share could come up after the parentheses and multiply its way backwards. That rarely happens, but when you encounter it, that's true. Rather than worry about that all the time, say, ooh, improper, I'm going to say that most of the time that it's the parentheses that follow it. Okay, so we're not going to worry about those funky situations that come up later. And you're also not going to be able to say, oh, Knossos said it always follows. I did not say it always follows. It's about multiplying across the parentheses, but the parentheses have a tendency to show up second. Let's look at 2 times 3 plus 4. And let's figure out what would order of operations, which you might call PEMDAS, tell us to do with that. And 2 times 3 plus 4 with parentheses around the 3 plus 4 will get me 2 times 7. 2 times 7 is going to let me double the 7 and get 14. What's distributing? 2 times 3 plus 4, I'm going to take my 2, which I'm going to change the color of it to green. Same stuff, but it's got a green 2 for tracing. And I'll make these other 2's green also. So we can see that they're actually the same 2, getting the same outcome, but doing the job a little differently. And this is what I'm going to do. I am going to share my green 2 as a multiplier with the 3, and share my green multiplier as a 2 with the 4. And therefore, I'm going to get this doubles to 6, this doubles to 8, 6 and 8 will get me 14. Same answer. Did you want to double the 7 when it was done first, or did you want to double the individual pieces of what eventually made up what was the 7 for you, but get it all the way to 14? That's your choice. Here's where you don't have a choice. I'm going to put my 2, and in here, I'm going to have, so my black parentheses have been here all the time, I'll go black parentheses again. And I want to make sure that we see 3x plus 4y. Now this is in that homework that we'd be working on, but 3x plus 4y are in the parentheses, and your job would be to combine them, if it's possible. The label on this is x, the label on this is y. Are they like terms? No. Because they are not like terms, they can't make 7 anything. They can't make 7 xi or something like that. You gotta go, keep the 3 here for x's, keep the 4 there, and let's double each one in its place. Here's my 2x, plus here's my 4y. Sorry, 2x, that's crazy. Come on, Knossos, get that right. 3. All right, here we go. 2 times the 3 with the x, and 2 times the 4 with its y. And now you'll get 6x plus 8y. And now the parentheses are gone. So now can we combine them? No, that's still got a label of x, still got a label of y, but the parentheses are gone. And that gave us the possibility of combining like terms, which might happen as the expressions get a little bit more complicated. So distribution is required when you have parentheses and the expression inside contains more than one term. What's in the parentheses is stuck as 2 terms. You cannot get that 2 to get to work on a 7. There is no 7. You got to get the 2 to work on the 3, 2 to work on the 4. That's where distribution comes in. Some teachers teach distribute, distribute, distribute. Always distribute when you see parentheses. That's a bad idea because of the amount of work you have to do. A lot of double negatives show up that way. When we can make what's in the parentheses a single expression, it's always been our job to get it into a single expression. So we simplify it as much as we can, and then we go after distributing if we still need to. Because this one we didn't need to distribute. We could go 2 times 7 and get our answer. So what we're going to look at here is we want to get rid of the parentheses. That could be by combining terms inside to a single term or distributing. but we are going to get rid of the parentheses. It hurts so much to get rid of keep the label, but it's true. What we're going to do is to simplify an expression. When I say get rid of the parentheses, you have to follow legal math rules. Number one, you got to get rid of the parentheses. To do that, you either get it down to one term and then multiply if there is multiplying, or you distribute. But it's not always distributing. Number two, combine like terms. Our first goal is, and hopeful goal, is that we don't have to distribute, but that we can get one term to multiply by. When that doesn't want to happen, we don't have to say, oh, can't do it. We got to recognize that we can't do it, so we don't force ahead and say, that's what I got, I'm happy with it. We've got to go ahead and distribute. So distributing is a tool to spread the factor across multiple terms in parentheses. That's what it's looking at having us do. That's what we've got to do. So I'm going to have us look at some distributing that we have here. 3 times 4x plus 5y. And that's going to get us 3 times 4x plus 3 times 5y. Wait, why didn't I make something in the parentheses? They're not like terms. No 9 of anything. 12x plus 15y. Can I combine those? No. Put I back here? No. They are stuck as separate terms, unlike terms. Negative 5 times 4a minus 9b. Let's get that fully simplified. That means I cannot see any parentheses when I'm done. They have to be taken care of. Step 1 guarantees that. And number 2, I've combined like terms. I can't leave any like terms uncombined, saying like, yeah, today I didn't feel like doing 7 minus 4, so I'm just leaving it as 7 minus 4. Your job is to combine like terms if they exist, but if they're not, then you can't combine them. So let's see what this guy's got going on. I'm going to help with a little bit of color. Negative 5 up here. Okay, let's go after those parentheses. First look, can I combine 4a and negative 9b? Wait, what did he say? Can I combine 4a and negative 9b because it's plus negative 9b? The answer is no, a isn't the same as b. Labels don't match. So I'm going to write my 4a and my negative 9b. I'm going to bring my plus sign right here, and I'm going to take my negative 5 right to them. It's a multiplier because parentheses, when they don't have anything else going on, parentheses are telling you to multiply. Negative 5 times that, and negative 5 times, okay, that's not negative 5 minus 9b, that is negative 5 multiplying by those terms. So I got a single negative. When I do 5 times 4, I get negative 20. And I got my blue plus sign. I'll keep it blue for us. And I have a green negative, or I should say I have a green dash and a black dash. I have 2 dashes. When I multiply 9 and 5, I'm going to get 45. The 2 dashes is an even number of dashes. That makes that not being, it doesn't have an odd number of dashes that would make it negative. It winds up being positive, and it's got its b here. This guy had his a here. Because one was an a term, one was a b term. Do I get 25 of anything? Do I get 65 of anything? No and no. I distributed negative 5 to both terms. Negative 5 times 4 is negative 20 with an a. Negative 5 times negative 9 gets me the opposite of negative for positive. 5 times 9 gets me 45, and that's a b. They're still not like terms, so you combine like terms. Well, I want to say combine like terms means you combine like terms where possible. You must do it everywhere it's possible, so you can't leave them uncombined, and you can't combine any that aren't like. Only like terms must be combined, and in the end, all like terms must be combined. So we're going to go on with that. Now, when we're combining like terms, it's still true. We're going to keep the label. If the label can't be kept because they don't match, they don't belong together. This is not a Romeo and Juliet, all right? Montague Capulet situation. We're not going to take troubling numbers and let them get together, no matter how much they want to. This is not a romantic situation. It's got to be about terms that truly belong together. So let's simplify these expressions. One would be 14 times 2x minus 5x. Now we have some things we're supposed to do, right? 14 will be green. just so you can see it. And I've got my 2x and my dash 5x, and I've got my plus sign. Let me ask you, label on 2x, x. Label on negative 5x, x. Matching labels, yes. Combinable like terms, yes. 2 plus negative 5. Subtract for a 3, strong on the negative, get your x. There's what your parentheses made. I still have my 14 out there, and the parentheses still exist, so I haven't gotten rid of them yet. But inside those parentheses, I was doing work that involved combining like terms. So you don't say, I'm not combining any like terms till the parentheses are gone. No, in the parentheses is where your focus is going to be. You do what you got to do. Here, that would be to combine like terms. But I say it's what you got to do. You have another option, which would be to distribute. But now 14 times negative 3, you multiply that out, you get a 42. A single negative, here's your x, and you're done. Okay? What I don't want to see people doing is turning this into 28x minus 70x, and then working on it that way. You can, because the distributing always works, but it makes for larger numbers, more work, and so forth. When you have like terms, you're going to eventually have to deal with them. If they're trapped in parentheses, let's deal with them right away. Expressions can sneak up on you and get trickier. That's why we save the combining of like terms as like the last thing we look for before we say we're done. There's no more terms than 1, so that's done. 2 parentheses around x minus 3 minus 4. What's that supposed to be? Let's see. We got a 2 in front of x and a dash 3, close. We got a dash 4. I got a couple things I need to put in there. I'm glad I have enough colors. I'm going to put the 1 in front of that x to see what's going on here. I'm going to put a plus sign in front of that negative 4, and we're going to go after what's got to happen here. We got to get rid of the parentheses. That's 1x, that's an x term, that's a number term. Let's see what happens. Can x and that negative 3 combine? Are they like terms? If so, tell me what the label is. What, you can't tell me? That's because there's not a matching label. They're not like terms. So I'm going to have to go with 2 times my 1x a little slow for me, but I forgot to put the plus right there in front of the minus 3. Okay, so now I have the plus. Plus separates terms. I've said that the whole time. You know, we're trying to combine like terms. The plus signs are key to freeing them up. Now I have 2 times my negative 3. The parentheses are gone because I've distributed them away. And I have plus negative 4. I need to make sure that this doesn't look like a dot. I need that to totally do its job of being a negative sign. Okay. Or in my straight up language, a dash. 2 times 1 with an x, 2x. Kept the label of x. 2 times 3 with a negative. Negative 6, no written label. Plus negative 4. So now some people might want to tell me that that is called 2x plus negative 6 plus negative 4. But if you have 2 like terms still there, you're not done. This is an x term, that's a number, that's a number. Check the negative 4, keep it in its column. Here we go. 2x plus negative 6 and 4 work together. We are adding, right? We brought the negative. Work together to get a 10, strong on the negative like the 6. And we have this. It's also known as, by lots of people, 2x minus 10. Here's what I like. That's acceptable. If Connect Math gives you a hard time with plus negative, you'll just get used to writing it as minus, because on the homeworks you'll get a lot of practice. And if Connect Math is intolerant, that's their fault, but it's our problem. And we would have to say 2x minus 10, but I'm pretty confident. I know for semester after semester they've been accepting of 2x plus negative 10. And to me that's better, because the first term is 2x plus the second term is negative 10, and I can see the label on that, and there is no label on that. I can see it's negative. So that's more useful than 2x minus 10. It does the same job, I won't deny it. Negative in front of 3y minus 10, which is in parentheses. Negative is right out there with 3y minus 10. Stuff going on here, huh? We got to simplify that. We cannot have parentheses. We cannot have like terms still sticking around when we do our simplification. So if I turn that into 3y plus negative 10, and I go ahead and I write my negative 1, now I'll work myself into a bit of a sweat here because I'm going to go negative. Well, the y term, the number term, can they combine? I hope you're saying no. Negative 1 times a 3 with a y. Now plus to start at the new term, which is blue, to start me up with the new term. I have this negative that started black, the 1 that I introduced as red, times the negative that started as minus, and the 10 that was there from the start. What do we have? We got a negative 1 times 3, negative 3. We have a y here. That is a y term. Plus, we have negative 1 times negative 10. 1 times 10 gets me 10. The opposite of negative is positive. There are no parentheses. There are no like terms. That is simplified. Simplify an expression. Don't say solve an expression. You cannot solve an expression. Solving comes when we start looking at equations, when they start having equal signs. We don't solve everything in math. Sometimes we simplify it. What that means is a mathematician thinks it looks better. Do you think that this looks better than the way that thing started? I don't know. But we have rules of what we can work with to get the more intense math done. And so we have to do some simplification, right, of expressions. So don't call everything solve. I know it's tempting, but simplifying is different from solving, just like expressions are different from equations. Yes, simplify and solve both start with S. Yes, expression and equation both start with E. So that doesn't help very much. You know, it looks like we're trying to confuse you. But you can only simplify an equation to make it look like a better looking version of itself. You can solve an equation to find out what number it's hiding. And we aren't solving anything yet. We have more to do here though. We have 5x, then dash 3. We have another dash, then we have parentheses around x plus 6. And our job here is to fully simplify that thing. We'll write it all over again. 5x dash 3 dash parentheses x plus 6. And stuff's got to get in there. Okay. 5x, wrong color. 5x plus negative 3, separating terms, plus the dash. I got some 1s here too. Number 5, number 3, no number 1, no number 1. That's got a number 6. All right, let's see what happens here. 5x doesn't change. Plus negative 3 doesn't change. Plus, I have negative 1 times 1. These 1s get multiplied to have a single dash. Negative 1x. Plus, negative 1 has to reach the 6. It doesn't just hit the 1 and say, I'm out, done, did my job. It's got to reach the 6. It has to go there. It's not a choice. You can't say, oh, I forgot the negative. No, you didn't forget it. You neglected it. Difference. Forgetting is when you like look at something on your way out the door and you forget to pick it up. Neglecting it is not knowing to deal with it. Here we go. This is what I have. I can't give anybody that answer as my best looking form of this equation. 5x is the x term. 3 is my first number term. Negative 1x. I've heard x before. Check and move. Negative 6 is a number. I've heard a number before. Check and move. It stays its same value with its same sign, but it relocates. 5 plus negative 1, subtract for 4, strong on the positive is my x term, plus negative 3 plus negative 6. They work together, get me a 9. Strong on the negative, I get that. It's also known as 4x minus 9. I like that. Negative 4. Then let's have parentheses around n dash 9. Then let's do plus, and let's go 3 with parentheses around n plus 1. Rewrite. Negative 4, parentheses n dash 9, close, plus 3, parentheses n plus 1, close. I gotta put some stuff in there. You see, I don't have to put the 1 in here where it is a 1. But here's where I need some 1s. I need 1n, and I need 1n. I need a plus sign. I only need one plus sign here. It's when it did n minus 9. I got that. Okay, let's get to it. Parentheses, I can't combine n and 9, an n term and a number term, so they don't get together. I got a negative 4 times 1, negative 4 with an n, plus negative 4 times negative 9. 4 times 9 will get me 36. The first and the second dash that has, 2 is even. That is not a negative on that 36. Plus 3 times 1, 3 with an n, plus 3 times 1 with no n is that number. Am I done? No. I finished this. I got rid of the parentheses. I have to combine like terms. Negative 4n is my first n. Here's something you can bank on. The first term will never have a check on it. The first term gets you started and can be the first column, and after that we'll see what hits it. Negative 4n is an n term. Plus 36 is a number term. Plus 3n. I heard n before. Check the n. This positive 3n is going to move over here. Continue. The number 3, number 36. Move the 3 as itself, positive 3. Okay, remember, you may be fighting old bad habits that teachers taught you to confuse you. They didn't try to confuse you, but they sure did a good job of it. We only take the 3 as it is and move it here. And now it's represented, and this means I've moved you elsewhere, you're still in play. All right, negative 4 plus 3, that's going to get me a negative 1, right? It's going to get me subtraction for 1, strong on the negative, the label is n. Plus 36 plus 3, both they work together, 39, and that could also be known as negative n plus 39. They might not have the 1 there, but you do need the plus in front of the 39. It could even be 39 minus n in some people's ways of writing stuff, but that's what's going on when we're looking at the core process of combining like terms. The problems will get a little bit more involved as we work further into the semester, but the concept of getting rid of parentheses followed by combining like terms, that is the key to our simplifying expressions. And you need to come back to this when we're solving some of the more tough equations that come after exam 1. So now I want to take a quick look at rounding some integers. I want to round a number, and this is the way we do it. Number 1, write all the digits up to the digit we are rounding, and one more. Number 2, after that, we write zeros for whole numbers, or B, not D, B, drop digits for decimals, because you don't want to look that far. Now there's some tricky stuff that goes on when you work in science called significant figures. That doesn't have to do with this. That has a lot to do with how accurate your measuring devices are. And it confused me because it wasn't clearly explained to me. So when you hit significant digits, don't think of it so much as rounding as it is to how good of a scale do I have, how accurate of a meter do I have, stuff like that. But here we are. We're going to drop the digits if we're in the decimals. We're going to put zeros to the decimal point if we are up above. And then number 3. Do the last 2 digits round up or down. Do that and lose your last digit. Now, when you lose your last digit, if you are a decimal, you drop it. If you are a whole number, you put a 0 there. Here's what we got. Let's see. We're going to take 2.3579, round to, and I'll put a word here, and then I'll do the work beside it. We want to round this thing to thousandths with a TH. Okay? There are no units. That's our tenths, hundredths, thousandths. That means we do want to write 2.357 and 1 past it. This is what we're going to round with the 9. 79 looks like 80. So I turn that into 235. Nothing changes in front of the 7. 79 looks like 80, so I make it 80. I'm dropping the 0 because it's a decimal, and I'm done. hundredths. This is where the 5 is. So we go 2.35. I give you one more with the 7, and I'm deciding whether it's 50 or 60. 57 goes to 60. 20 is 2.360, but it's decimal, so I drop what's after it, and I get that. Now we get to the tricky one, tenths. Now the tenths I'm looking to round, and I got 35. So a lot of people are like, oh no, 5 is in the middle. 5 is not in the middle, okay? I'm gonna show you why 5 is not in the middle. I'm gonna start, 0 is the lowest. Okay, I'm gonna take off the 0, I'm gonna take off the 9, take off the 8, take off the 1, take off the 2, take off the 7, okay? Take off the 6, take off the 3, take off the 4, take off the 5. Where's the 5? The 5's on the high side. 5's go up. 5's go up. 5's are not in the middle. 0, 1, 2, 3, and 4, they drop down. 5, 6, 7, 8, 9, they go up. This is going to go, 35 goes like 40. This is 2.4. Don't write the 0. You got that. Quick demonstration when the numbers are above, right? When they are decimal, not decimals. How do we round when we have numbers that aren't decimals? Let's just take 7, 8, 9, 430. 2, let's go to hundreds. And we'll go to 10,000s. To hundreds. We're going to go to where the 4 is. We go 7, 8, 9, comma the 4. We're going to be looking at the 3, and that's what we're going to look at. Right? There's another space right back there. But 43 looks like 40. So we go 7, 8, 9, 40, and then we finish out with zeros, and that's what we got. To the 10,000s, that's where the 8 is. 7, write the 8, look at the 9 as well. Now I definitely have 3 more zeros back there because that's what's going to finish me out. Now I could put them as blanks, but I'll park them up as zeros because I got this number. 89 looks like 90, so I go 79, and then the rest are zeros. And that's how we round numbers. Zeros will get me to the decimal, and if I'm past the decimal, they will drop off and represent that I'm not looking that far into the digits. Okay. This wraps up our lesson 6A.